The most challenging question you could ever ask in a scientific inquiry is, what is the origin of a thing? And it's challenging whether or not the question involves life. It's for an obvious reason. Nearly everything we ever study already exists. And so you can study its past, you can look at it in the present, and you can maybe extrapolate to the future. And in so doing, you build a timeline of its life, right? So that works. But how about the start of it? How about the beginning? How about the transition between it not existing and existing? So in the universe, knowledge of our sun's birth would ordinarily be completely inaccessible. Because how are we going to get back there and then? We can't. Fortunately, billions of stars in our galaxy exist in all phases of life and death. So we can use them as proxy for our thoughts about the sun. We can infer how the sun was born, and we can infer how the surrounding planets were born here by looking deep within massive clouds of gas and dust in our own galaxy. That requires special telescopes, of course, to not only see the surface of the clouds, but use wavelengths of light that dig deep down and see where all the action is. But with life on Earth, as far as we know, there was only one Genesis. And if there's only one, there's not another way to compare other forms of life that were born separately from ours, that have different origins. Let's go back then and imagine, at some point there was a conversion of inanimate organic molecules, comprising elements such as carbon, hydrogen, oxygen, nitrogen. These are the traditional elements of what we call organic chemistry. At some point there was a transition of inorganic molecules into animate, self-replicating creatures. That would have happened about 4 billion years ago. And that transition today remains inaccessible to us. And as a consequence, remains a mystery. All right, because of this, it greatly challenges our efforts to duplicate the phenomenon in the laboratory. We don't see it happening it could be, but we don't see it happening anywhere else. Now, the modern tree of life has a level of depth and complexity that Darwin and perhaps even your parents' biology teachers wouldn't even recognize. As far as we've ever measured, all life on Earth has common genetic heritage. That's what the tree of life means. Everyone branches from, you go back in time, there gets fewer and fewer branches, and you reach a point where there's only a single branch. So, an example of this, dig far enough back in time, and you will find the common ancestor between any two people on Earth, the common parent. Dig far enough down the tree of life, and you will find the common ancestor to any two species on Earth. I don't care what they are, you can find it. How about humans and chimps? That's in the recent past. How about humans and goldfish? That's a little farther back. How about humans and toadstools? Humans and yeast cells? There is a point where you will find the common ancestor for any two branches of modern life. And so, as far as we've been able to determine, there's been only one Genesis on Earth. So, in order to help out this effort to understand life and how it got here, what we need is a second Genesis on Earth, or an ensemble of planets out there, all with different stages of formation of life on them, just as we've done for the formation of stars and planets in the galaxy. This is some of what motivates the search for other planetary systems out there. If we find them with life, let's get the inventory of them all and compare and contrast. So, what we need to ask, however, is, on Earth, since life happened pretty quickly, almost as quickly as it could have, took place within a couple of 100 million years, why hasn't there been a second or multiple coexisting parallel trees of life on Earth?